Dude, we are live. What's up, guys? This is Dem Keys, and today we are not going to be doing a study stream necessarily. It's going to be more of a research kind of stream. Which I mean, to be fair, even during study streams we do research. Give me a second. Okay, yeah. So to be fair, even during study streams we are doing research, but today we are mainly just going to be googling stuff and asking. Well, in this case mostly asking, well, no, okay, it's gonna be a mixture of googling stuff and asking a language model questions. I have a list of topics that I kind of wanted to do some research on. Cutane, hello, welcome to the stream. We're going to be doing a bit of research today, a bit of AI related research. um, Unfortunately, our our talking stream streak, I guess I should call it. It was broken at, I guess, 8 streams. I think we managed to do 7 or 8 talking streams in a row before my schedule kind of went all over the place, and then I wasn't able to stream. But today I managed to stream again, and hopefully I'm able to uh, maintain this for, because, like, dude, I mean, being able to do a week, being able to do talking streams for a week straight, I'll take it. I'm not complaining. I wasn't expecting it to, you know, last for very long, because that's just the way things are on my end. Unfortunately, sometimes due to um, due to certain circumstances, I'm just not able to stream. It is what it is. But yeah, dude, if I'm able to do another week straight of talking streams, I'll take it. But in the meantime, I do want to rush with building my TTS tech, and later on I can sort of build the STT tech as well. Oh, actually, that reminds me of a couple of other questions that I want to ask. So, okay, let's prepare the list. I don't know how much of this list we're going to go through, or how much of this list we're going to get through on stream. Regardless whether I get through, wait, how do I want to phrase that? Regardless whether I finish all of them on stream or not, or regardless of how many of them I finish on stream, I'm definitely planning on finishing this entire list. So even if I am not able to finish researching all of these topics on stream, I'm definitely gonna do the remaining ones off stream. Okay, so what was I trying to do? I was trying to create a code cell. Actually, no, I was just trying to create a cell so that the UI would kind of get fixed, and then I would have this option to create a markdown cell. Okay, now there's a couple of items in the list. I just remembered 2 items, so I think I'm gonna write them down before I forget them. Uh, what was the first one? FFmpeg um, to stream live audio. I've looked into this, and it seems like, yes, through FFmpeg, you should be able to um, stream it out. I don't remember. Oh, yeah, yeah. Okay, so it does give you a couple of different options. We're gonna read up on it. I did do a bit of reading on it beforehand as well. And it turns out, yes, it has multiple options. One that I'm particularly interested in is being able to stream um, from one machine to another, not necessarily having to stream from one machine to a server and then, you know, broadcasting it from the server to various clients. That's a more, complex and sophisticated setup, which I don't really need. Quite literally, what I'm looking for is streaming from one machine to another. Because my idea with both the TTS tech and the STT tech is that the entire processing is going to take place on a different system. And the audio is also going to be generated on that different system, which is not going to be this main system, this streaming system. And the main reason I'm doing that is so that I don't put a big load on the streaming system, because I'd imagine the model that is doing the actual audio generation, it's going to put a bit of a load on the system, and I don't want that load coming onto my streaming system, because as it is, my system is not all that powerful to begin with. So my idea is I'm going to set up the entire program on a different machine, and I'm going to type out whatever I want to say, and then that text is going to be fed into the AI model, into the TTS model, and the TTS model is going to produce audio, which has to then be played, right? But I'm not going to play it immediately. I'm going to stream it to this machine, the streaming machine, where it will then be played. That's the idea. Um, how well this is going to work, I'm going to have to find out. I'm not sure. Oh, actually, yeah, that brings me to my next thing, which is Firebase. So I'd read up, actually, no, I'd seen the name Firebase mentioned a bunch of times before. Give me a second. Okay, yeah. So I'd seen Firebase mentioned a bunch of times before by a bunch of developers. They were using it in their projects. I didn't really understand at the time too much about what it was for, but I remember looking it up and seeing that it was something cloud related, cloud infrastructure related. So I was like, okay, I can look into this later. For the time being, I don't really need it. And then today I read up on something to do with Gemini and Firebase, and I found out that there's something called Firebase Studio, and even more importantly, and this is what grabbed my attention, I found out that there's a free tier for it, which means I can explore it and test it out and see if it can be useful for me. So that got me interested in it. And so I'm going to be doing research on Firebase as well. And then we have three other topics. Uh, One was Llama Nemotron Nano. There's a couple of different versions of this model. Nano is the smaller one, which is meant to run on like consumer devices, not you don't necessarily need, well, okay, I want to say that you don't necessarily need a high-end device, but I'm not sure to what extent that's true. I think it's more Nano works on like a high-end machine, whereas the models that are bigger than Nano, you kind of need to run them in a cloud infrastructure. I could be wrong about this. It could also just be that Nano runs on lower end devices, or it could run, I guess, on lower end devices, because they did mention, we're gonna look up the model card for this, and then you guys will see. So Llama Nemotron Nano, that's a language model, and there are various other versions. We're gonna look at those versions as well. But the reason I said that I think Nano is meant to run on high end machines, and then the higher versions, the versions higher than Nano, are kind of meant for even more powerful infrastructure, is because of the hardware mentioned for inference. first of all, I don't know if these models run on CPU because they've specifically mentioned a bunch of GPUs. They haven't mentioned anything about CPU inference, so I'm guessing they need a GPU. I don't know if they run on the CPU or not. Another thing, so Nemotron brought up another doubt. I had to do research on Nvidia Nemo. I did come across Nemo a while back, and I found out that it's some kind of framework from Nvidia for deep learning related stuff. But like, in what way, I didn't exactly understand. Like, I didn't necessarily know the details surrounding Nemo. And then today, when I was reading up on Llama Nemotron, I mentioned no, I noticed that it mentioned that the inference engine was Nemo. So I was like, okay, what does this mean? Because if Nemo is the framework, then what exactly does this mean when it says that the inference engine is Nemo? Does that also mean that the Nemo framework includes an inference engine which can be used? So we're going to read up on NVIDIA Nemo and Nemotron. Actually, funny enough, I'd also read up on, I hadn't read up on it. I'd heard about and looked a little bit into Nemotron as well a while back. I didn't go too deep into it. Okay, the last thing that we're going to be looking into is this agent to agent. This is an open protocol, an open source protocol. Yeah, I guess you can call it an open source protocol. I believe this is by Google, and this is for it's a protocol to establish communication between two AI agents. At least that's my understanding. And well, I want to get a better understanding of it to make sure that I'm right about that, and to understand exactly what this protocol does, what's the design like, and what kind of problem is it trying to solve. Just a second. Uh, Give me a minute. I'm just gonna open. Well, no, it's fine. Okay, so these are the five things that I need to do research on. Um, what should we start with? Okay, we can start with NVIDIA Nemo and Nemotron. So we are gonna ask, you know what? We can probably ask the question to DeepSeek instead of Sonar Pro. Okay, so I already asked this question to Gemini on a different machine. So let me just read that question. Okay, so I'm seeing models like Llama, Nemotron, and the model card mentions that the inference engine is Nemo. I don't understand. How exactly are we meant to run the model? And isn't Nemo some kind of framework? Okay, okay, all right. Uh, okay, cool. So let's read its thought process first. Okay, so the user is confused about how to run the Llama Nemotron model since the model card mentions the inference engine is Nemo. They're also unsure if Nemo is a framework. Let me break this down. First, I need to clarify what NVIDIA Nemo is. From what I remember, uh, Nemo is a framework developed by NVIDIA for building and training AI models, especially in the speech and language domains. Yeah, it's part of their ecosystem, so probably uses PyTorch underneath. Okay, but the user is talking about inference, so maybe Nemo isn't just for training, but also for deploying models. Now, the model they mentioned is Llama Nemotron. Wait, Llama is from Meta, right? But Nemotron is NVIDIA's series of models. Maybe this is a collaboration or a variant, or maybe it's a mistake in the model name. Or maybe Nemotron is a family of models that includes a Llama-based architecture. I need to check that. Alternatively, perhaps the user saw a model card that mentions Nemotron and Nemo together. Let's assume that the model in question is part of the Nemotron series by NVIDIA, which uses the Nemo framework for training and inference. Okay. So the user is trying to run this model. The model card says the inference engine is Nemo, so they might be thinking, do I need to use Nemo to run this model? They might be confused about they might be confused because they're used to models being run via either hold on. They're used to models being run via Hugging Face's transformers or something similar. I like that it made that assumption, and yeah, that assumption is correct. I'm used to running them either through Hugging Face transformers or just directly through PyTorch. Actually, to be honest, at this point so far, it's mainly been transformers. It hasn't even been PyTorch. PyTorch is so far what I've done is building models with it. Okay, but Nemo is a separate framework. So steps to run the model would involve installing Nemo, loading the model using Nemo's API, and then running inference. But I should outline this process. But I should outline that process and also mention that Nemo is indeed a framework, not just an inference engine. Maybe the model is trained and optimized to work within the Nemo ecosystem, so they provide scripts or examples in Nemo for inference. Potential issues the user might face. Needing specific dependencies, compatible hardware like NVIDIA GPUs, and maybe the model being in a specific format, being in a format specific to Nemo. Also, the user might not be familiar with Nemo's API, so pointing them to NVIDIA's documentation or GitHub examples would be helpful. I should also clarify the difference between Nemo the framework and Nemotron the model family. Nemotron models are likely part of NVIDIA's offerings, but no, not but built using Nemo. So the user needs to use Nemo tools to run them effectively. Another point, sometimes models can be converted to Onyx or other formats, but if the model card specifies Nemo, it's probably best to stick with their tools. You know what? That's a good point. I should keep this in mind for the future, that even if a model card specifies a certain inference engine, if I get my hands on the model, then there's very little that's stopping me um, from trying to convert the model. So I need to try and run experiments to see if there is a way for me to convert these models. Like even if it does say that, yeah, this is meant for so and so inference engine specifically, there's nothing stopping me from converting it to, let's say, the Onyx format and then trying to run it. I don't know if it's going to be successful, but there's nothing stopping me from trying, you know? That's where the experiment That's where the experimentation aspect of everything comes in. Um, where was I? Yeah, okay. But if the model card specifies so and so, it's probably best to stick with their tools. Maybe NVIDIA has optimized the model for their framework, ensuring better performance or compatibility. Very true, very true. Include a sample code snippet showing how to load a model in Nemo. Check if the model is available on Hugging Face but requires Nemo for certain features. Also note that Nemo might have dependencies like PyTorch, NVIDIA GPU drivers, CUDA, etc. Possible alternatives. If the user doesn't want to use Nemo, maybe not. Wait, what? Possible alternatives if the user doesn't want to use Nemo? Maybe not, since the model is tied to it. So the answer should guide them through Nemo setup and usage specifically. Also mention that Nemo is more than just an in is what hold on, what? Also mention that Nemo is more than just inference. It's for training too, but in this case, the focus is on inference. Highlight the steps, install Nemo, load the model, run inference with their API, maybe provide links to resources. Make the answer clear step by step, so and so, so and so, so and so. Okay, all right. So to run models like Llama Nemotron that specify the NVIDIA Nemo inference engine, here's a clear breakdown of what you need to know and how to proceed. What is Nemo? Nemo is a framework, not just an engine, developed by NVIDIA for building, training, and deploying AI models, particularly for language, speech, and vision tasks. It's built on PyTorch and optimized for NVIDIA GPUs. Think of it as a specialized toolkit for NVIDIA optimized models, offering offering pre-built modules, scripts, and tools for tasks like inference, fine-tuning, and distributed training. Nemotron versus Nemo, clarifying terms. Nemotron, a family of open source models released by NVIDIA. These models are trained with NVIDIA's tools and optimized for their ecosystem. Nemo, the framework used to run these models. If the model card says Inference Engine Nemo, it means that the model is designed to work best with the Nemo ecosystem. Okay, how to run Llama Nemotron. To use NVIDIA Nemo models, follow these steps. Install NVIDIA Nemo. Okay. All right. Load the model. Use Nemo's APIs to load pre-trained models. Okay, so Nemo has a collection of models in it. Good to know. Good to know. Okay, okay. Hold on, dude. This is actually good to know. Also, I like this from pre-trained, kind of like how they do in Hugging Face transformers. Run inference. Okay, so we load the model first. Okay, cool. Then we run inference. The API is pretty similar. Okay. Hardware requires an NVIDIA GPU. Model availability. Nemotron models may be hosted on NVIDIA NGC or Hugging Face Hub, but they often require Nemo for full compatibility. Customization. Nemo provides tools for fine-tuning, quantization, and deployment to Triton Inference Server. Okay. Alternatives to Nemo. If a model is specific, no. If the model is exclusively tied to Nemo, you'll need to use the framework. However, some models might be convertible to formats like Onyx or Hugging Face Transform. Wait, what does it mean to convert the model to Hugging Face Transformers? I should look into that because I know about like the devs of Transformers adding support for these models, but I haven't come across a thing where it's like you convert the model to a certain format that is meant for Hugging Face transformers. Or maybe if I have come across it, I didn't realize that that's what it was. Anyways, check the model card or contact NVIDIA's support for details. Okay, all right. Let's open up the Nemo documentation. Uh, NVIDIA provides Nemo tutorials as well. Good to know. We're gonna look into that as well. While these two things load, let's go back to our question. So we kind of cleared up both of these. Okay, so we can write done and done. Okay. Now, next, I think we should go to Firebase after this. Let's finish reading this first. Okay, NVIDIA Nemo is a development platform for building custom generative AI models. The framework, the framework supports custom models for. Hold on. The framework supports custom. I just noticed text to speech, and suddenly I'm very much interested. Okay, the framework supports custom models for language, multimodal, computer vision, automatic speech recognition, which that's TTS, NLP. No, did I say TTS? That's STT, speech to text, speech recognition. Um, NLP and of course TTS, text to speech. Um, okay. NVIDIA Nemo framework is a scalable and cloud native generative AI framework built for researchers and developers working on large language models, multimodal, and speech AI. Oh, and speech AI. It enables users to efficiently create, customize, and deploy new generative AI models by leveraging existing code and pre trained checkpoints. Okay. All right. Let's learn more. Guess we can close this now. Okay. Right. Okay. Should we read this stuff as well? Or hold on. What is Nemo Run? Is this for inference? Like, is this specifically for inference? I wonder. Um, okay. Two options. Oh, there it is. So, two options are available to launch training in Nemo. Use the Nemo 2.0 API interface or with Nemo Run. With Nemo Run, Nemo Run provides an interface to streamline configuration, execution, and management of experiments across various compute environments. This includes launching jobs on your workstation locally or on big clusters. Okay. Using the Nemo 2.0 API, this method works well with a similar setup involving small models, or if you are interested in writing your own custom data loader, training loops, or change model layers. It gives you more flexibility and control over configurations and makes it easy to extend and customize configurations programmatically. I think I want to go with Nemo 2.0 API. Um, Mostly because it also mentions customizing the model. Okay. So, yeah, deployment and inference. Nemo framework provides various paths for LLM inference, catering to different deployment scenarios and performance needs. Okay, deploy with Nvidia Nim. Okay, all right. Let's take a look at the quick start thing. No, not quick start. What there was something else here that yeah. Let's take a look at the getting started tutorials. Distributed data classification. Okay, okay. This this shows how to run a simple training loop using so and so. It uses the train API from so and so. Okay. Oh man, I'm starting to yawn, dude. Holy shit. To be fair, I just managed to make it. I managed to stream um very close to the end of my day. But like I wanted to get a stream in, so I was like, nah, we're gonna do it. I actually wanted to stream yesterday as well, but oh shit, there's an ad playing right now. Okay, so I'm gonna take a hydration break, and I'll see you guys in 30 seconds. All right, welcome back. So, um, right, I'm. Hold on, dude. I'm really wondering if I need to be looking into this right now because a lot of this seems okay. Let's take a look at deploying models. A lot of this seems like the framework makes it easy to build scalable models. I could be wrong about that, but like it does seem like it makes it easier to build scalable models, and of course also, train and run the models and also fine tune models. I I don't know, maybe okay, let's read on. Let's read. Yeah, no, maybe I need to read up more on this to see. Okay, so my main, like, what I'm wondering as I'm reading more and more about this, what I'm wondering is if I need to look into Nemo right now, or if I should leave it for later on. Like, am I going to be able to use this for, like, the smaller models, or is this more beneficial when you're talking about bigger models? Because I could definitely, like, I mean, I have an Nvidia GPU, though I don't know if my Nvidia GPU would be able to run these models, or I don't know if Nemo would be able to leverage my GPU given how old it is. Because it, like, Nemo, it targets specific architectures, but more importantly, it targets architectures past a certain point. And I feel like my GPU's architecture is before that point, not past that point. Basically, meaning my GPU is pretty old, so I'm not entirely sure if my GPU would be useful in this case. I mean, either way, reading up on it doesn't hurt. Okay, so Nvidia Nemo framework offers various deployment paths for Nemo models tailored to different domains such as LLMs and multimodal models. There are two primary deployment paths for Nemo models: deploying Nemo models with exporting to inference optimized libraries such as TensorRT, TensorRT LLM, or VLLM, and deploying Nemo models at the PyTorch level, both with the NVIDIA Triton inference server. To begin serving your model on these two deployment paths, all you need is a Nemo checkpoint. While a number of deployment paths are currently available for different domains, others are still in development. As each unique deployment path is as each unique deployment path for a domain becomes available, it will be added to this section. Okay, all right. Let's take a look at this. Deploying PyTorch level models involves running models directly within the Nemo framework. This approach is straightforward and eliminates the need to export models to another library. It is ideal for development and testing phases where ease of use and flexibility are critical. The Nemo framework supports multi-node and multi-GPU inference, maximizing throughput. This method allows for rapid iteration and direct testing within the Nemo environment. Although this is the slowest option, it provides support for almost all Nemo models. Um, okay, so here they are mentioning that models can leverage inference optimized libraries such as TensorRT and so on, so on, so on, so. Uh, okay, all right, okay. What does the examples section contain? Or rather, I should say, what kinds of examples does it contain? Um, let's say TTS. Okay, I'm gonna be honest. I'm not getting too much from this. Mostly because I'm not really sure how to explore the example. I'm I'm looking at more complex examples than what I want to be looking at. Hold on. Is there something down here? I don't know. I feel like I need to explore this later on some more to get a better idea of like how I'm meant. Wait, okay. What did it mention here? Like this is it? Like you just you load up the model, and then you can, well, I mean, it's gonna have to download the model and the weights, or more importantly, the weights. You have to download the weights, and then you just run inference using this model, or using this library. I mean, if it's that simple, hold on. Let's test this out. Let's see if this works. Nemotron 38B. Dude, I hope I'm able to run this without any, content gating. Um, I think it might be downloading it off of Hugging Face. I'm not sure. So we need Nemo. Is Nemo part of? I don't know if Nemo is a part of. I don't know if Nemo is a part of the libraries that are installed within a Kaggle notebook. So let me check. Let's try import Nemo. Uh, no module named Nemo. I guess not. Okay, let's try this. Yeah, no. Nemo is not installed. We'll have to install Nemo first, which, okay, let's do this. So, pip install, what is it? Nemo toolkit, Nemo underscore, Nemo underscore toolkit, and then all. I hope it's not a very big thing to install. Okay, okay, okay. Yeah, it doesn't seem that big to install, but there's just a bunch of things that have to be installed. A bunch of like smaller things, which it's a good thing that it's smaller. Okay, it is still going. Okay, it's slowly becoming bigger and bigger, like in terms of what I need to download. Okay, all right. We are going. Oh, wait, shit. The model itself is also gonna be big. So I guess we're gonna have to wait for that to download as well. Okay, are we done? I don't think it's done installing just yet. Yep. Okay. Keep going. Keep going. It seems like it found existing installation. Oh, that's interesting. So I think it's uninstalling things that it needs to install newer versions of, because it's saying it found an existing installation of so and so, and then it's attempting to uninstall it. I'm assuming it's attempting to uninstall because it needs to install. Okay, maybe not newer versions, maybe specific versions, I guess I should say. Pip's dependency resolver does not currently take into account all the packages that are installed. This behavior is the source of the following dependency conflicts. Okay, we have a problem. I think this is done executing. Okay. So let's see if this works. Okay, it works. Nemo.collection collections.nlp.models. Okay, maybe I should have specified. That was a mistake. Okay, from models, I want specifically something called empty encoder decoder, I'm assuming, model. Oh, there's an error. Okay, so let's say this empty enc decoder model. No module named Megatron Core. Okay, let's try running the installation thing again. It's definitely not going to be downloading everything again. We can clear this out. Okay. Yeah, so it's going to be a bunch of requirement already satisfied messages. And it seems like it's done. Okay, no module named Megatron.core. Let's see if the thing comes up again. Right. Let's look this up. Nemo, no module named Megatron.core. Okay, somebody asked this question in the Nvidia developer forum. Now let's see what the answer is. Problem solved. I'm using the wrong environment in Jupyter Notebook. You're using the wrong environment. Am I supposed to download an environment? I didn't realize that. No, I don't think, wait, what does, hold on. Let's take a look at install. Okay. Recommended Docker container. Nemo framework supports large language models, multimodal. Okay, all right, fine. Recommended for LLM and MM domains. MM is multimodal. Then we have Conda and pip. If you are an using an NVIDIA PyTorch container as the base, this is the recommended method for all domains. Right. What if I'm not using Docker? We strongly recommend that you start with a base NVIDIA PyTorch container and install Nemo and its dependencies inside. If doing so, run the container and go to step 3 directly for pip instructions. Okay. It seems like, yeah, it seems like there's a bit of a separate setup for this. It's not, apparently it's not as simple as just installing Nemo. There's a couple of other steps that you have to take. So I'm going to step away from Nemo for now, and we're going to move on to something else. I am curious about this though. Let's take a look at Auto Model. Nemo Auto Model is a workflow within the Nemo machine learning framework that supports both pre-training and fine-tuning large language models, designed to accelerate your journey from data to deployment. Whether you're whether you're a researcher or a developer, Nemo Auto Model makes it incredibly easy to fine-tune state-of-the-art models from Hugging Face with minimal setup. You'll benefit from day zero support. Models available on Hugging Face Hub can be fine-tuned instantly on your own custom dataset. Seamless Hugging Face integration, rapid experimentation, distributed fine-tuning, and accelerated iteration. Okay, all right. You know what? We're gonna step away from Nemo for now. I do want to come back to it at some point in the future. I'm curious about this. So I'm gonna ask the question here. Okay, I have a Kaggle notebook, and it turns out that Nemo is not installed in it. So I tried installing Nemo underscore toolkit all. But when I tried importing MT Enc deck model, I got an error saying no module named, what was it? Megatron. Megatron.core was found. I did some research and found out that the recommended method is to use one of their provided Docker containers or Conda environments. Help me understand why that is and how that is different from just installing Nemo into my own environment. Should I ask this to DeepSeek itself, or I think okay, let's ask it to DeepSeek, because in the thought process there might be some extra information. Okay, so okay, the user is trying to run the Nemotron model in a Kaggle notebook. They installed Nemo Toolkit but got an error about a missing so and so. Now they're asking why the recommended approach is using Docker or Conda instead of just installing Nemo in their own environment. First, I need to figure out why Megatron.core is missing. Nemo probably depends on Megatron LM, which is a separate library by Nvidia for large-scale models. The error suggests that when they installed Nemo Toolkit, it didn't pull it didn't pull in Megatron as a dependency, or maybe there's a version conflict. The user mentioned that the recommended method is using Docker or Conda environments. Actually, okay, it might be the version conflict thing. It could also just be that it didn't install that specific dependency at all, which I'm not sure why that is. I should explain why that's the case. Docker containers and Conda environments provided by Nvidia come pre-configured with all the dependencies, including specific versions of PyTorch, CUDA, Megatron LM, etc. Nemo is a complex framework with many dependencies that might not be compatible with the versions already present in Kaggle's environment. That makes sense. Yep, that makes sense. When the user installs Nemo via pip, it might not handle all these dependencies correctly, especially if some packages are missing or conflicting. In Kaggle's environment, the base Docker image might not have Megatron LM installed. The pic the pip the pip package for Nemo might not include Megatron because it's a separate project. So the user has to install it. But even then, there could be version mismatches. For example, the version of PyTorch in Kaggle might not be compatible with the version required by Nemo or Megatron. The core issue is the dependency management. NVIDIA's Docker or Conda environments ensure all components are compatible. Without that, the user has to manually install each dependency with the correct versions, which can be tricky, especially in a managed environment like Kaggle, where they might not have full control. Okay, all right, now I get it. Now I get it. I need to, because of how complex Nemo is, I need to run it within their own environment, be it through their provided Docker container or their provided Conda environment. So I'm going to leave it for later. I'm not going to touch Nemo right now. I'll run it later on when I'm better prepared to set up the environment. Okay, cool. So we can move on from Nemo now, and we can ask the next question, which was about Firebase. We can refresh this. I've been learning, hold on. I've been learning how to build AI models with PyTorch. I've also been learning how to use Google AI Studio to do various interesting things using Gemini. Today I came across something called Firebase and Firebase Studio. I'm wondering what this is and how it can be helpful for me. Okay, all right. Uh, Starting from the top. Okay, so the user is learning about PyTorch for building AI models in Google AI Studio with Gemini. Now the user came across now they came across Firebase and Firebase Studio probably meant Firestore or Firestore database. No, that's not what I meant. But now I'm wondering if Firebase Studio specifically is something new. Um, and so maybe DeepSeek doesn't know about it. So maybe I should ask Gemini this question. Problem is, oh yeah, I know how I can do it. Give me a second. We're gonna open up Google AI Studio. What was it? aistudio.google.com, I think. Yeah, yeah, okay. And we are ready to get started. Um, I think I can go with Gemini 2.5 Pro preview because hopefully it's going to have more up-to-date information. I'm still going to read whatever DeepSeek just wrote because DeepSeek is going to have the information about Firebase. Maybe it doesn't have the information about Firebase Studio. Um, Wait, we are still on BRB. Let's get rid of that. Okay. Um, right. Hold on. How do I get rid of all of these things? Actually, yeah, we're good. How do I get rid of this thing? I forgot. Give me a second. Okay. Okay. This definitely needs to be zoomed in. Oh, this is probably going to take some time. Oh, okay. It's never mind. It's not going to take time. Okay, let's break down Firebase and how it fits in the picture with your PyTorch and Gemini experience. First, a clarification. Firebase Studio versus Google AI Studio. It's highly likely you're slightly mixing up names here. Google AI Studio, this is a web-based tool you're already familiar with for prototyping and experimenting with Google's Gemini models. You use it to test prompts, adjust settings, and even get basic code snippets. Firebase, this is a separate. This isn't. Wait, Firebase Studio, this isn't a standard, widely known official product name like Google AI Studio you might have encountered. No, hold on, dude. Wait a minute. No, we're gonna. I think it's just that it's so new that neither of these. Oh, you know what? Wait. I just remembered. Hold on, let's go back here. I just remembered that some of these models have the ability to check on the internet. So let's try Gemini 2.0 Flash. And let me try asking the question again. Grounding with Google search. That's what I was looking for. So we're gonna rerun this. Okay. Okay, I understand you're exploring Firebase and Firebase Studio and how they might fit into your AI slash PyTorch and Gemini learning journey. Let's break it down. Okay, Firebase. We're gonna read up on Firebase. What is Firebase Studio? Cloud-based AI development environment. Firebase Studio is a cloud-based environment designed to help you build, test, deploy, and run AI applications. It's designed to streamline full stack app development. Okay, so it's probably just that it's pretty new, and that's why the models don't really know about it. Uh, Wait, Firebase Studio for rapid AI prototyping. Use Firebase Studio with Gemini to quickly generate functional web app prototypes with AI features. It can automatically wire up GenKit. What is GenKit? Wait, let me look this up. GenKit. GenKit Firebase, code first framework for orchestrating, developing, and monitoring generative AI workflows. That's interesting. Okay, all right. Okay, deploying PyTorch models. You can deploy your trained PyTorch models using Firebase. This typically involves converting your PyTorch model to TensorFlow Lite format and then deploying it using Firebase ML. Okay. GenKit for AI features. Okay. Gemini API integrations. Vertex AI for PyTorch. Firebase extensions. Connecting to Google AI Studio. Okay. Let's read up on what exactly Firebase itself is. Okay, Firebase backend as a service. Firebase is a platform that provides a suite of cloud-based tools and services to help you build, deploy, and scale web and mobile applications. It handles the backend infrastructure so you can focus on the user experience and front-end development. Key features, authentication, and so and so and so and so, cloud storage, hosting, cloud functions. I need to look into since you're able to host apps here, I need to look into what kind of resources are available to you. More specifically in the free thing, what kind of resources are available to you? Okay, let's take a look at what yeah, it's pretty much the same thing. Okay, okay, so the user is into AI, so I should focus on how Firebase complements AI development. Maybe they want to deploy their models, handle user data, or integrate AI features into apps. Firebase can help with backend services so they don't have to manage servers. For example, using Firebase hosting to deploy a web app that uses their PyTorch model or Firebase functions to run server-side logic, maybe inference if the model is lightweight. Also, Firebase authentication could manage user access to AI features. Sorry, give me a second. Okay, all right. Um, okay, storage wise, Firebase storage can store models or data sets. Firestore can keep user data or results from AI processing. If they're using Gemini for generative AI, maybe the model can model no, maybe they can build an app that uses Gemini via Firebase functions, handling API requests securely. They might not know that Firebase offers ML Kit, which has on device ML APIs. But if they're using PyTorch, maybe they need custom models. Firebase can still handle the app backend. Also, Firebase provides analytics and monitoring, which could help track how their AI features are being used. Should mention that Firebase is serverless, scales automatically, and integrates well with Google Cloud Services. If they're using Google AI Studio, combining it with Firebase makes sense for a full stack application. Maybe give an example: building a chat app with Gemini integration, using Firestore for chats, Firebase auth for users, and hosting for the front end. Check if there's confusion between Firebase products like Firestore versus so and so. Clarify that. Also, note that Firebase is not for training models, but for deploying apps that use models. Okay, good to know. Good to know. If they need heavy computation, might need Google Cloud API platform instead, but Firebase is for the app side. Okay, okay, yeah, I feel like that's something to take into account. That's also one of the reasons why I kind of wanted to know what kind of resources were available. Okay, Firebase is a backend as a service platform developed by Google designed to simplify and accelerate the development of mobile and web applications. It provides a suite of tools and services for handling common backend tasks like authentication, database, storage, hosting, serverless functions, and more without requiring you to manage servers or write complex backend code. Here's how Firebase and its tools like so and so, so and so, so and so can complement your AI projects. Okay, maybe the next question should go to Sonar. I didn't quite understand what exactly does Firebase do? Is it mainly hosting the app? If so, what kind of resources are available for us? Also, if Firebase isn't necessarily a cloud service, then how exactly is it hosting the app? I have to ask these questions in like a very, specific way so that the model gives me the kinds of answers that I'm looking for. Because the way that I phrase these questions, it may seem kind of silly, but like I'm intentionally, asking the questions in that way. Also, to be honest, in quite a lot of the cases, the questions that I have are just outright what would be considered silly. um, I never consider questions to be silly, even if like the questions are coming from like a beginner. I don't really consider them silly because the reason you're asking these questions is because you don't know. But yeah, anyways, I do quite often phrase the questions in very specific ways because I know that the model is gonna give me the answer in a certain way and give me certain types of information that I'm looking for. Okay, Firebase is a cloud-based backend platform developed by Google that helps develop that helps developers build, deploy, and scale web and mobile applications without the need to manage physical servers or complex architecture. It handles many backend tasks for you, including hosting your app, managing databases, authentication, storage, and running server-side code. The core purpose of Firebase is to make app development faster, easier, and more secure by providing tools and infrastructure as a service. Okay, what exactly does Firebase do? Firebase offers a suite of cloud services you can use in your project: hosting static and dynamic web pages, app hosting for full stack apps, database services, authentication. Wait, the AI stuff would come under app hosting. Yeah. Okay. Um, authentication, cloud functions, cloud storage, analytics, and performance monitoring. Okay. Is Firebase mainly for hosting apps? Hosting is a major feature, but it's one part of what Firebase offers. Think of Firebase as a full featured cloud backend. Here's how the hosting part works. Firebase hosting, Firebase app hosting. Okay, okay. You can choose between these two. Okay. What resources are available with Firebase? I should have been more specific about what I meant by resources. Okay. How does Firebase host your app? Firebase is absolutely a cloud service. When you deploy your app with Firebase, your files or code are uploaded to Google servers via the Firebase CLI or continuous integration tools like GitHub Actions. Okay, okay, okay. Um, yeah, I should have been more specific about what kind of hardware resources are available. What kinds of hardware resources are available when using Firebase to host an app? Oh shit, I wrote has an app. I hope it understands. Hold on. Okay, Firebase offers a suite of cloud-based services that provide developers with various hardware resources and infrastructure capabilities without having to manage the underlying hardware directly. Here's a detailed overview of so and so. Compute resources, cloud functions. Firebase Cloud Functions provides serverless compute resources that automatically scale based on demand. Um, Key aspects include automatic scaling, concurrency, okay, flexible runtimes, execution time. Functions can run for up to 60 seconds with HTTP triggered invocations. Cloud Run, containerized environments, okay, higher concurrency, up to 1,000 concurrent requests per container instance. Containers scale based on incoming requests. Hold on, dude. That is interesting. It's not, I don't know. Maybe I'm just, maybe it's because I haven't slept yet that I'm not really understanding this. But like, or maybe I'm just used to the format being mentioned in a different way. Like, for example, when I had seen it on, let's say, Hugging Face Spaces, for example, um, or on, I think Replit was another one. I think it's called Replit. I'm not sure. Replicate? No, I think it's Replit. I think Replicate is a different. So is Replicate a thing? Hold on. Wait. Replicate Code Farmer. What is Code Farmer? On Replicate. Replicate.com. What is Replicate? I know what Replit is. What is Replicate? Run AI with an API. Okay, fine. Replicate is its own thing. Okay, so yeah, I'm talking about Replit. So we have Hugging Face Spaces, and then also Replit, and like there's a bunch of other different, cloud-based services where you can like run, you can host apps essentially for running AI models and stuff, and they provide you with specific information about the hardware, like this much CPU, this much memory, this much storage, stuff like that. So I guess that's kind of what I was expecting here, but I feel like here they're doing it in a different way. The way that they're approaching providing resources is, it might be a little different, or maybe I'm just, not properly understanding it. That could also be possible. But yeah, I definitely want to look into Firebase more, and I'm going to look into Firebase more, and then I can figure out if it is for me or not. Especially since now there's some kind of like Gemini integration with it, so that should be interesting. Like seeing what I can build with, let's say, Google AI Studio, and then maybe deploy on Firebase. And if it seems useful enough, then maybe I could use it for other purposes as well. Like, I don't know, running my TTS model, for example, just, as an example. Though, I mean, if I'm running my TTS model on the cloud, any cloud service for that matter. I mean, it could be a Hugging Face space as well. It doesn't necessarily have to be Firebase. I could set up a Hugging Face space, and then I would have to set up some kind of, how do I go about that? Yeah, I would have to figure out a way to send data and then, well, send the text to the app that is running on the cloud or in that Hugging Face space, and then have it be processed and have it spit out the audio file, and then have the audio file be downloaded. I have to figure out how to go about doing that, because there's definitely going to be, um, API keys involved in there, or at least one API key involved. I also need to see if it's going to be required at all. I'm not entirely sure if. No, did I say required? No, I have to see if it's going to be worth it. I mean, there's fortunately there are like free, or there is one free tier. I don't know if they have multiple types of free tiers, but they have at least one free tier, and then they have like multiple levels of, like, different types of hardware, and then it's like a pay as you go kind of thing, which is great. It's amazing. So you pay based on how much of the hardware you are using. So at some point, if I need, then I can start running things in the cloud instead of running it on my own machine. But for the time being, yeah, I'm going to be running the TTS model on one of my machines locally. That should be a start. That should be a start. Though I should definitely look into doing the thing like on the cloud. I'm not sure where though. Hugging Face Spaces would be a start. Yeah, yeah. I should look into that. What else was remaining in the research that we were supposed to do? So I think Firebase is done here. I did want to look into agent to agent. I'm still going to be looking into it. And then FF MPEG, I need to look into this because this is necessary for streaming the audio across the network. I could very easily just send the raw files, but my assumption is that if I set up some kind of like streaming thing, then there's going to be maybe some kind of codec involved, meaning there's going to be a certain amount of compression, and hopefully that should be a little faster in terms of getting the audio to the other side. And there might also be some other stuff that makes things faster, some other stuff that I don't know about. Okay, now give me a second. Okay, today I'm kind of sleepy, so I'm not feeling very chatty. So what I'm gonna do is, uh, because usually I like to stick around and chat with the person after the raid, but like today my brain is kind of just, like, yeah. So here's what I'm gonna do. We're gonna raid Little Witch Oz. Oz is cool people. Oz is a friend. She's a game developer. She's she's a gamer as well. She plays a bunch of different games. Today she's doing right now actually she's doing some game development stuff. So we're gonna go hang out in Oz's stream, and I'm probably gonna fall asleep um, in a little bit. Maybe I'll eat something first. I'm not sure. But yeah, that's going to be it for today's stream. I'm hoping I'm able to stream tomorrow as well. Let's see. Let's see if that happens. But I'm hoping. I'm able to stream, do a talking stream more specifically tomorrow as well. Qtane, thanks for hanging out. Thanks for stopping by. Appreciate it. Anyone else who might have been lurking in the chat, thanks for hanging out. But that being said, I hope you guys have a nice day, and I'll see you all next time. Peace.